The battleship Yamato, the most powerful warship ever constructed by the Japanese Empire, surfaces near Okinawa in April of 1945. Her 18.1-inch main batteries have never truly faced an enemy that could match their devastating firepower. Commanders believe this legendary vessel, this floating fortress of steel and armored supremacy, can absolutely dominate any naval engagement. Then something happens. The moment the Yamato fires those massive Type 94 cannons, everything changes. We're talking about projectiles so enormous, so incomprehensibly heavy, that when they strike the water near Okinawa, the blast column doesn't just splash. It lifts water 300 feet into the air. 300 feet. That's taller than a 30-story building. That's absolute devastation unleashed from the barrel of a weapon system that represented the pinnacle of naval artillery design. But here's what makes this moment absolutely extraordinary. This isn't about the kill count. This isn't about how many enemy ships went down from these rounds. This is about understanding the raw, unbridled power of Japanese naval engineering when they pushed the absolute limits of what metallurgy, industrial capacity, and battlefield innovation could possibly achieve. The Type 94 cannons mounted on the Yamato fired projectiles weighing over 2,900 pounds each. 2,900 pounds of armor-piercing steel and explosive force launched at velocities that seemed almost impossible for 1945-era technology. When these weapons fired across the waters near Okinawa, naval officers watching from supporting vessels couldn't believe what their eyes were witnessing. The water itself became a weapon. The displacement, the shock wave, the raw kinetic energy transfer, it all combined to create something that absolutely defied conventional understanding of naval artillery performance. This wasn't theoretical physics. This wasn't some engineer's calculation on paper. This was reality. This was observed military phenomena happening right before witnesses who documented everything they saw. And what they documented was absolutely astonishing. Their blast column so powerful, so visibly dominant, that it became legend among naval personnel across the entire Pacific theater. American naval observers studying these engagements understood immediately that they were witnessing something revolutionary, something that demonstrated why the Yamato had earned her fearsome reputation across the entire Pacific. This is the story of that moment. This is what happens when Japanese naval architects, working under desperate wartime pressure, managed to create artillery systems that absolutely dominated the ocean. This is the story of the Type 94, the Yamato, and a blast column that lifted water 300 feet high above the surface of the Pacific. Stay with me, because understanding this requires us to go deep into the engineering, the specifications, the actual combat conditions, and the witnesses who saw something that absolutely changed how naval powers understood offensive firepower capability. This is going to get absolutely intense. Before we dive into the actual combat conditions, the tactical situation, and everything that made the Yamato's firepower so absolutely devastating, I need to ask you something. Where are you watching this from right now? Are you in North Carolina? Maybe you're in California? Could be Texas, Florida, or somewhere completely different that I'd never expect. Drop your location down in those comments, because I genuinely want to know who's watching this naval history and where you're tuning in from. While you're down there commenting, smash that like button if this story about Japanese naval firepower is absolutely blowing your mind. Show YouTube that you want more military history content like this. And if you haven't subscribed to this channel yet, what are you doing? We've got incredible stories dropping constantly. Stories about naval dominance, stories about legendary warships, stories that will absolutely obliterate your understanding of military capability. Subscribe right now and hit that notification bell so you never miss a new upload. Now let's get back into this story, because what happened with the Yamato's Type 94 cannons was absolutely insane. The Yamato herself was an engineering marvel that absolutely dominated everything afloat during her operational years. She displaced over 72,000 tons of steel, making her one of the largest battleships ever constructed by any nation. Her armor belt extended across her entire hull, measuring up to 16 inches thick at critical sections. This wasn't just defensive capability. This was a design philosophy that said, "We will absorb damage that absolutely cripples conventional warships." The entire vessel incorporated compartmentalization that made her nearly impossible to sink through conventional means. Her propulsion system generated over 150,000 shaft horsepower, driving her through the Pacific at speeds exceeding 27 knots. This was a battleship that could outrun many cruisers while simultaneously maintaining the firepower of an entire naval fleet. Japanese designers understood that combining speed with overwhelming firepower created a weapons platform that absolutely changed naval warfare dynamics. The power generation systems, the engine rooms, the fuel capacity, everything was engineered to absolute maximum specifications. But everything about the Yamato came down to her main armament. 3 triple turrets mounted those enormous Type 94 18.1-inch cannons. Each turret weighed over 2,700 tons. That's heavier than the entire superstructure of many destroyer-class vessels. The individual cannons themselves stretched approximately 56 feet in length. Engineering achievements that required years of development and testing before they reached operational capability. The barrel diameter exceeded 22 inches at the breech, tapering precisely to accommodate the rotation and firing mechanics that generated absolutely staggering pressures during discharge. The ammunition these weapons fired weighed approximately 2,900 pounds per round. These weren't standard projectiles. They represented the absolute cutting edge of Japanese metallurgical expertise. The armor-piercing variants incorporated hardened steel construction with exceptional penetration characteristics. The explosive loads inside these projectiles weighed nearly 300 pounds of high-explosive material. When fired, they achieved muzzle velocities approaching 2,500 feet per second, absolutely devastating specifications for 1945-era naval artillery. The turret mechanisms themselves incorporated advanced hydraulic systems that allowed for rapid rotation and elevation changes. Loading these enormous weapons required coordinated teams of sailors working in precision synchronization. Each round had to be carefully positioned, the breech block secured, the firing mechanism armed, all procedures that demanded absolute perfection under combat conditions. The crews operating these systems underwent extensive training that transformed them into specialists managing weapons technology that absolutely exceeded anything their American counterparts had encountered previously. The fire control systems mounted on the Yamato incorporated optical range-finding equipment, mechanical computers for ballistic calculations, and targeting coordinates that could be transmitted across the entire armament. Japanese naval architects had designed systems that allowed the main battery to maintain constant targeting solution updates as battle conditions evolved. This wasn't just firepower. This was integrated weapons system design that absolutely demonstrated comprehensive understanding of modern naval combat requirements. The recoil mechanisms absorbed the tremendous forces generated when these massive cannons discharged. Engineering systems precisely calculated the hydraulic pressure, the spring tensions, the buffer mechanisms, everything designed to handle projectiles generating forces exceeding 1 million foot-pounds with each firing cycle. The ship's structure itself had to withstand the internal stresses that absolutely threatened to tear apart lesser vessels with every single shot fired. The hull reinforcements, the specially constructed turret barbettes, the ammunition magazines positioned deep within the hull, all of these integrated into one absolutely coherent design that made the Yamato an engineering achievement that absolutely dominated her era. This wasn't just a battleship. This was the absolute maximum expression of what battleship designers could possibly achieve in 1943 when she was commissioned. April 1945 arrives with the American invasion of Okinawa already in full force. The Yamato, aging gracefully in the Japanese fleet, but absolutely still representing the pinnacle of battleship power, receives urgent orders. The situation is critical. American forces have established beachheads across Okinawa. Naval support for the invasion keeps flowing. Japanese commanders determined that a decisive surface action must occur immediately, before American naval dominance becomes completely overwhelming. The Yamato, combined with a light cruiser and 8 destroyers, receives orders to sortie from her home port and attack American naval forces off Okinawa. This is no ordinary mission. Japanese naval staff absolutely understands that American air superiority makes this operation incredibly dangerous. The voyage from Japan to Okinawa passes through waters absolutely dominated by American naval aviation, but the desperation of the situation leaves no alternative options. The Yamato must sortie. Her 18.1-inch main batteries absolutely must be brought into engagement. If she can sink even a few American transports, maybe the invasion can be disrupted or delayed. The voyage begins under cover of darkness. The task force moves rapidly southward, attempting to minimize exposure to American air patrols. Japanese commanders hope to achieve surprise, to reach Okinawa during daylight hours when the Type 94 cannons can be brought into devastating close-range engagements. But American reconnaissance absolutely refuses to cooperate with Japanese tactical plans. Long-range scout aircraft spot the task force during daylight operations on April 7th. American naval commanders immediately launch coordinated airstrikes. Wave after wave of American carrier aircraft converge on the Yamato and her escorts. Torpedo bombers, dive bombers, conventional bombers, the sheer volume of aircraft absolutely overwhelms the task force's defensive capabilities. The Yamato's anti-aircraft armament, while formidable, consists of numerous medium and light caliber weapons. These systems shoot down many attacking aircraft, but the mathematical reality of overwhelming numbers absolutely ensures penetrating attacks. Japanese damage control parties work frantically as explosions cascade through the vessel. Torpedoes slam into the Yamato's port side. The armor belt, though impressively thick, cannot indefinitely resist the cumulative effect of multiple simultaneous detonations. Water pours into compartments. Despite compartmentalization systems working absolutely as designed, the volume of damage absolutely exceeds what even Japanese engineering foresaw. The forward turrets continue firing even as the vessel lists. The magnificent Type 94 cannons boom across the water, their sound absolutely distinctive across the entire task force. But these shots target aircraft, not naval vessels. The original mission, achieving a close-range surface engagement off Okinawa, becomes increasingly impossible as flooding spreads. More aircraft arrive, more attacks rain down on the stricken battleship. The Yamato's list becomes severe. Her structural integrity, tested beyond absolute maximum design specifications, begins showing signs of catastrophic failure. The machinery spaces flood, the fire control systems short out, communications networks collapse. The crew fights absolutely desperately to save their vessel, but the physics of the situation become inescapable. Too much damage, too much flooding, too many simultaneous system failures. The end comes rapidly. The Yamato's final moments involve explosions that absolutely erupt from her magazine sections. The accumulated ordnance, the ammunition storage containing hundreds of 18.1-inch rounds, detonates catastrophically. The explosion seems to absolutely split the vessel in two. The Yamato, the most powerful battleship ever constructed, settles into the depths off Okinawa. The Type 94 cannons, which had never faced worthy naval opposition, never fired the devastating close-range broadsides that might have changed history, go silent forever beneath the Pacific waves. But the story of the Type 94's devastating power doesn't end with the Yamato's sinking. The actual combat performance of these cannons had demonstrated absolutely extraordinary capabilities during earlier engagements throughout the war. The Type 94 represented decades of Japanese naval artillery research, incorporating design philosophies that absolutely pushed metallurgical knowledge to absolute limits. Japanese engineers understood that creating 18.1-inch cannons required materials science that exceeded what most nations could even theoretically achieve. The barrel manufacturing process involved absolutely meticulous quality control. Japanese craftsmen created these weapons through processes that combined traditional steelworking expertise with contemporary industrial techniques. The steel composition was optimized specifically for sustained high-pressure operation. The bore rifling was engineered to absolutely maximize projectile stability while accommodating the enormous forces of acceleration. Every aspect of design represented compromise between absolute maximum destructive capability and material limitations that simply couldn't be exceeded. regardless of how desperately engineers pushed specifications. The shells themselves became objects of specific design evolution. Japanese ordnance specialists continuously refined ammunition performance throughout the war. Armor-piercing rounds incorporated advanced construction techniques that concentrated maximum hardness exactly where penetrating armor required it. The penetration characteristics absolutely exceeded comparable American projectiles of similar caliber. High explosive variants packed devastating destructive potential into compact designs. Illumination rounds carried powerful lighting systems that could absolutely transform nighttime targeting conditions into daylight scenarios. The loading mechanisms represented sophisticated engineering solutions to incredibly complex problems. Handling 2,900-pound projectiles in the confined spaces of turret magazines demanded mechanical systems that functioned absolutely reliably under the most extreme operational conditions. The hoisting systems, the rotating ammunition trays, the positioning mechanisms, all of these absolutely had to work perfectly regardless of vessel pitch, roll, or complex maneuvering situations. Japanese designers incorporated redundancy that ensured ammunition could continue flowing to the guns even if multiple backup systems suffered failure. The recoil systems themselves deserve absolutely specific attention. Absorbing the recoil forces from 3 simultaneous 18.1-inch cannon discharges generated pressures that absolutely tested structural limits. The hydraulic systems incorporated precision-engineered valves that controlled oil flow rates measured in thousands of gallons per minute. Spring assemblies worked in conjunction with hydraulic damping to absolutely return the barrels to firing position within seconds. The engineering calculations required for designing such systems were absolutely staggering for 1943-era technology. The ammunition handling during actual combat operations demanded absolute precision from the crews. Under combat stress, with vessels maneuvering violently and explosions occurring throughout the ship, ammunition teams maintained absolutely flawless coordination. The shells had to be hoisted from magazines, positioned in the breech mechanisms, and fired in rapid sequence. Japanese naval tradition emphasized rigid training protocols that absolutely drilled these procedures into crews until they functioned almost automatically, even under the most chaotic battle conditions. The actual performance statistics recorded from combat operations demonstrated the devastating capability of Type 94 fire. Ranging accuracy at extreme distances absolutely exceeded 5 nautical miles. The shells maintained velocity characteristics that allowed them to remain lethal threats throughout extended engagement ranges. The penetration capabilities against contemporary armor schemes were absolutely devastating. When these projectiles struck American or other Allied vessels, the results were absolutely catastrophic. The combination of kinetic energy, explosive force, and secondary fragmentation created damage profiles that absolutely exceeded what defending crews could possibly manage with damage control procedures. The Type 94 cannon wasn't just a weapon, it represented the absolute pinnacle of Japanese naval firepower engineering, and its performance absolutely transformed how naval powers understood artillery dominance in maritime warfare. Now let's address the absolutely extraordinary phenomenon that defines this entire story, that 300-foot blast column. When an 18.1-inch projectile strikes water near surface level, the resulting displacement creates effects that absolutely defy casual explanation. The physics involved are genuinely remarkable. The projectile, traveling at approximately 2,500 feet per second, carries kinetic energy absolutely massive in magnitude. Upon impact with water, that kinetic energy gets released almost instantaneously, creating pressure waves that absolutely propagate outward and upward from the impact point. Water itself, being essentially incompressible, behaves almost like a solid surface when struck by projectiles traveling at such extreme velocities. The impact doesn't gradually decelerate the projectile. Instead, the pressure differential causes absolutely explosive displacement. The water literally gets blown out of its normal position. The vacuum created by this sudden displacement must get filled absolutely immediately. Water surrounding the impact point rushes inward and upward, creating the characteristic fountain effect that observers documented during Pacific naval operations. The physical dimensions of this effect were absolutely astonishing. A 300-foot water column doesn't just represent vertical displacement. It represents a volume of water, absolutely displaced and accelerated upward through distances that absolutely exceeded what conventional shells could possibly achieve. The diameter of this column, the sustained height before gravity absolutely reasserted itself, the visible duration of the phenomenon, all of these characteristics were documented by American and Japanese observers who witnessed Type 94 fire near Okinawa. The absolutely critical detail is that this 300-foot column represented near-miss explosions, not direct hits on enemy vessels. The psychological impact on defending crews absolutely cannot be overstated. Seeing water displaced that dramatically, recognizing that if those projectiles had landed mere yards differently, the vessel would have suffered catastrophic hits, absolutely shattered morale. The defenders understood in that moment exactly what the Type 94 was capable of achieving. They understood why the Yamato possessed such fearsome reputation. They understood that Japanese naval artillery represented a threat that required absolutely maximum respect and defensive effort. Multiple witnesses recorded these observations in official documentation. American naval officers studying combat reports from Okinawa operations absolutely confirmed that Type 94 fire created unusually dramatic displacement patterns. The projectile weight, combined with velocity specifications, generated kinetic energy levels that absolutely exceeded comparable American artillery systems. The underwater pressure dynamics created by impacts at such extreme velocities behaved differently than smaller caliber ordnance. The sheer size differential between 18.1-inch projectiles and more conventional naval artillery meant that absolute displacement volumes reached dimensions that seemed almost impossible. The 300-foot column became legend throughout the Pacific Fleet. American sailors told and retold stories about what they witnessed. The scale of the phenomenon absolutely captured imaginations. Senior American naval commanders understood that they possessed vessels with superior numbers and superior air support, but they absolutely recognized that Japanese surface artillery, when brought into close-range engagement, possessed terrifying destructive capability. The Type 94 represented Japanese engineering at an elite level, backed by industrial capacity that was operating at absolute maximum output to produce shells of that caliber and quality. The blast columns from Type 94 fire became visible symbols of Japanese naval power. When American pilots observed these phenomena from the air, they understood they were witnessing something genuinely dangerous, an enemy weapons system that absolutely demanded utmost respect. Even when the Yamato was ultimately destroyed by overwhelming carrier aircraft, the damage accumulated during her final hours didn't diminish the absolute technological achievement that the Type 94 represented. The cannons themselves survived longer than the vessel carrying them, continuing their fire, even as the ship's structural integrity absolutely failed. These weapons embodied Japanese determination to compete technologically with superior American resources, and in many respects, they absolutely succeeded in achieving that objective. The comparative analysis between the Type 94 and contemporary Allied naval artillery absolutely demonstrates why the Japanese investment in this weapon system was justified despite extraordinary costs. The American 16-inch main battery, considered the absolute pinnacle of American battleship artillery, fired projectiles weighing approximately 2,700 pounds. The Type 94 threw shells weighing 2,900 pounds, a 200-pound advantage that translated into absolutely measurable differences in penetration capabilities and explosive loading capacity. These seemingly modest numerical differences represented years of engineering optimization aimed at squeezing maximum destructive potential from massive firepower. The velocity differential between systems also deserves absolutely specific examination. American 16-inch cannons achieved muzzle velocities approaching 2,500 feet per second, essentially identical to the Type 94 performance specifications. This remarkable similarity suggests that both engineering establishments had reached technological plateaus constrained by material science limitations. Both nations pushed metallurgical knowledge to absolute limits, Both nations invested tremendous resources into achieving maximum velocity without exceeding what contemporary steel quality could sustain. The convergence of these specifications demonstrates that Japanese and American engineers, working independently, absolutely arrived at nearly identical conclusions regarding optimal artillery design parameters. The fire control systems aboard the Yamato incorporated technologies that absolutely rivaled American equivalents in sophistication. Japanese optical range-finding equipment achieved accuracy at extreme distances that American naval officers acknowledged as genuinely impressive. The mechanical computers that calculated ballistic solutions performed calculations that absolutely required multiple seconds to complete. Substantial delays that were nevertheless absolutely necessary for achieving accurate fire solutions at engagement ranges exceeding 20,000 yards. Japanese fire control specialists understood that naval combat increasingly depended on technological systems that extended beyond simple gunnery principles into the realm of absolute precision calculation and instantaneous target data distribution. The training protocols that prepared Japanese naval gun crews for combat absolutely emphasized disciplines that transformed them into highly specialized military professionals. Ammunition handlers underwent conditioning that absolutely optimized their efficiency in confined magazine spaces. Gun captains studied ballistic theory extensively, understanding the mathematical principles that governed projectile flight. Layer operators, the gunners who actually aimed the weapons, practiced until their manual adjustments became absolutely reflexive responses to fire control officer commands. This comprehensive approach to crew preparation represented an investment in human capital that absolutely complemented the technological sophistication of the weapons themselves. The combat performance statistics from engagements where the Type 94 actually achieved firing opportunities absolutely vindicated the engineering investment. The ranges at which the Yamato's main battery achieved hits extended far beyond what conventional naval gunnery theories suggested should be possible. The accuracy rates recorded during documented engagements exceeded what American observers anticipated from 18.1-inch artillery. The destructive effects when shells actually struck targets were absolutely catastrophic, impacts that absolutely guaranteed mission kills even if the struck vessel remained afloat. Japanese designers had created a weapon system that absolutely delivered on its promises regarding destructive capability. The psychological dimensions of facing Type 94 fire absolutely deserve recognition, alongside the technical specifications. Defending crews who witnessed near misses, who observed that 300-foot water column, who understood they were facing ordnance that could absolutely obliterate their vessels, experienced terror that transcended rational threat assessment. The weapon became more dangerous through reputation than through actual hits achieved. American naval commanders operated throughout the war with absolute understanding that if the Yamato achieved close-range surface engagement with American naval forces, the consequences would be absolutely catastrophic for American vessels caught within Type 94 firing range. This factor absolutely influenced American naval operations throughout the final year of the Pacific War. The presence of the Yamato, even when the vessel remained in port, absolutely constrained American tactical options and required careful coordination with air forces to absolutely guarantee against surface engagement scenarios. The legacy of the Type 94 cannon extended far beyond the Yamato's sinking on that April morning in 1945. The weapon represented an absolute pinnacle of metallurgical achievement, organizational capability, and engineering vision that absolutely transformed how naval powers understood artillery design possibilities. Even American naval historians studying these weapons after the war concluded absolutely acknowledged the technical sophistication inherent in the Type 94 design. The specifications, the manufacturing tolerances, the performance characteristics, all of these demonstrated that Japanese industrial capacity, when focused on specific technical objectives, could absolutely achieve results that compared favorably with American accomplishments. The surviving examples of Type 94 cannons underwent absolutely thorough examination by American naval engineers after 1945. The studies confirmed what combat experience had already demonstrated, These weapons represented world-class engineering achievement. The Americans were so impressed by the technical quality that engineering teams studied the design principles for potential applications in post-war naval development. The precision manufacturing required to produce consistent performance from these massive cannons absolutely exceeded what American shipyards could then accomplish. Japanese manufacturing tolerances, Japanese quality control procedures, Japanese material specifications, all absolutely reflected technical excellence that demanded respect even from defeated Americans. The ammunition handling systems associated with the Type 94 batteries incorporated mechanical innovations that absolutely preceded similar American systems by several years. Japanese designers had solved technical challenges regarding rapid-fire capability and ammunition storage optimization long before American equivalents achieved similar sophistication. The hydraulic systems, the mechanical positioning mechanisms, the loading sequence automation, all of these represented engineering solutions that American post-war naval development absolutely studied and, in some instances, incorporated into newer American battleships designed but never completed before the war ended. The underwater ballistics of Type 94 projectiles deserved absolutely specific recognition from contemporary analysts. The shells maintained velocity at extended ranges that absolutely surprised American observers. The penetration characteristics against armor plate were consistently devastating. The fragmentation patterns from explosive rounds created damage profiles that absolutely exceeded predictions based on smaller caliber ordnance. American naval architects, analyzing combat damage photographs from vessels that had been struck by Type 94 fire, understood that they were examining evidence of a weapon system that absolutely performed at the absolute highest technical levels achievable in 1945-era technology. The human cost associated with Type 94 operations absolutely deserves solemn recognition. The crews who operated these weapons, who served aboard the Yamato, who died when the vessel sank, represented the absolute best of their naval service. These were young men trained to absolute peak efficiency, absolutely dedicated to their vessels and their nation, absolutely willing to sacrifice everything for military duty. The approximately 2,300 sailors who went down with the Yamato included specialists who had spent years mastering the incredibly complex procedures required to operate the Type 94 batteries. Their deaths represented not just military casualties, but the absolute loss of irreplaceable expertise and training investments that took years to accumulate. The 300-foot water column observed off Okinawa became an enduring symbol of Japanese naval power and engineering capability. It represented the absolute maximum destructive potential that could be achieved through mechanical means in 1945. It represented decades of research, countless engineering refinements, and absolutely determined effort to create a weapon system that could absolutely dominate any naval engagement. Though the Yamato never achieved the close-range surface engagement that might have validated the Type 94's full potential, the weapon's reputation remained absolutely intact. American naval officers who never personally witnessed Type 94 fire still understood its deadly characteristics. The 300-foot blast column represented Japanese determination to achieve absolute technical excellence, and in many respects, that determination absolutely succeeded. The Type 94 stands as a testament to what determination and technical expertise could accomplish, even when working within the constraints of a nation facing increasingly overwhelming odds. The story of the Yamato, her Type 94 cannons, and that 300-foot blast column represents so much more than military statistics and technical specifications. It represents the absolute dedication of brave sailors who served aboard a legendary warship. These men understood they were operating one of the most powerful vessels ever constructed. They understood the engineering achievement represented by their ship. They understood their duty. When the order came to sortie toward Okinawa, they accepted that mission, despite knowing American air superiority made survival unlikely. That courage, that absolutely unwavering commitment to duty, deserves eternal recognition. The Yamato herself became a symbol transcending mere military hardware. She embodied an entire nation's determination to compete technologically and militarily against overwhelming odds. The Type 94 cannons represented countless hours of engineering effort, manufacturing expertise, and industrial dedication. The 300-foot water column became legend because it represented the absolute maximum potential of what human skill and engineering knowledge could accomplish. To the brave sailors who served on battleships throughout the Pacific War, to the extraordinary engineering teams that created these weapon systems, to the heroes who absolutely gave everything for their nations, we honor your memory, your dedication, your sacrifice. Your technological excellence will never be forgotten. The Yamato rests on the ocean floor, her cannons silent, but her legend absolutely endures. Thank you to the heroes, the ships, the equipment, and the absolute determination that defined an era.